Welcome back. So, as I just talked about, we have two different ways we can calculate weights when we're looking at our value model. Well, first we'll talk about what we call AHP, the analytical hierarchy process, which was developed by Thomas Sadie. Without getting into all the details of it, the main crux of AHP is what we call pairwise comparison. Pairwise comparison allows us to compare one weight or one item to another, and it's a one-to-one comparison. All right, which is nice because it's much easier for some folks to just think one item versus another item versus instead of doing a one-to-many comparison. All right, and so we have a quick example down below of how we could actually read a pairwise comparison graph. So if we're talking about drink consumption in the US, if we're comparing and we have all these different beverages, right? We have coffee, wine, tea, beer, soda, milk, and water. So we have 7 different beverages. We'd start by building a matrix, right? A 7x7 matrix. And what these numbers represent is how much more the left-hand side, the row labels are consumed as compared to the column labels. All right, so obviously we'll have a one-to-one mapping when they align. So coffee is consumed 1 times as much as coffee. That's why there's a 1 when you're looking at the coffee to coffee mapping. Same for wine, same for tea, and we have, as you can see, that diagonal from the top left to the bottom right of just simply ones. And then from there, we can read across and say, coffee is consumed 9 times as much as wine. That's how we would interpret that. Coffee is consumed 5 times as much as tea. Coffee is consumed twice as much as beer. Coffee is consumed the same or 1 times as much as soda. Coffee is consumed the same as milk. And coffee is consumed half as much as water. All right, so we walk through the first row for drink consumption in the United States. And then what we do from there is we continue on, starting with wine. We would start wine to tea, and then wine to beer, wine to soda, etc. And we'd see we'd get 1/3, 1/9, 1/9, 1/9, and 1/9. Great, and we continue on. So we essentially fill out the top right portion of the matrix, and then we do not worry about the bottom half until we have completed the top right portion after it's divided by that diagonal of ones. All right, and then all we do is we take the reciprocal of our top right answers. So logic dictates that if coffee is consumed 9 times as much as wine, then wine, if we're looking at our second row, wine is consumed 1/9 as much as coffee, right? So we just put 1/9 and we just invert and we go from there. Similarly, coffee is consumed 5 times as much as tea. We see that in row 1. So then tea is going to be consumed 1/5 as much as coffee. That's why we have in column 1, 1/5. We have a 1 over. And it continues the same way, all the way to the bottom where we see water is consumed twice as much as coffee, which makes sense since we have in the top right a 1/2 for coffee is consumed 1/2 as much as water. So that's how we'd read a pairwise comparison matrix. And we'll go ahead and I'll give an example when we're talking about our car buying problem that we've talked so much about so far. All right, so we'll start with a comparison matrix, and let's say we're using value measures, and I have 3 value measures that I care about, right? So I have crash test rating, I have miles per gallon for city driving, and number of passengers. My first step when I'm building out my AHP or my pairwise comparison, my comparison matrix, I can just map ones from the top left to the bottom right. because I know crash test rating is as important to me as crash test rating. So I'll start by putting mapping a 1-to-1 ratios. And then the next question is, how important is crash test rating compared to city miles per gallon? And I will say crash test rating is 5 times as important to me as miles per gallon, so I'll give that a 5. I'll then say crash test rating is half as important to me as number of passengers, so I will give that a 0.05. Then I'll go to the next row. I only have one other to fill. City miles per gallon is, I'll say, a quarter or 0.25 as important to me as number of passengers. So I'll give that a 0.25. And then our next step, as we've talked about, is you'd say 1 over. So I'd say 1 over 5, and that'll give me 0.2. I'd say 1 over 0.5, and that'll give me a 0.5, or that'll give me a 2.0. And then 1 over 0.25, and that will give me a 4. All right, hopefully everyone saw how that worked. I just did a 1 over and then mapped directly on the diagonal, mapping essentially. So here, crash test rating to city miles per gallon got a 5.0. So then it should be 1 over 5.0, which is 0.2. So that's how we calculate out the bottom left-hand side of our pairwise comparison matrix. And then we take the sum. All right, so we sum each column, and that's how we come up with 3.2, 10.0, and 1.75. We then have to build what we call the normalized matrix. So our normalized matrix, we will go ahead and take for each of our value measures, our crash test rating, our city miles per gallon, and our number of passengers. So for crash test rating, I'll take that 1.0 in that top left cell and divide it by our sum for that entire column, and that's 3.2. So 1 divided by 3.2 gives me 0.31. I would do the same across, so I would say 5.0 divided by 10.0. 5 divided by 10 gives me a 0.5, and then 0.5 divided by 1.75 gives me a 0.29. So that's how I'd build out that first row for crash test rating. And then I take the average of all three and get 0.37. So that is my normalized weight for crash test rating. I would do the same for city miles per gallon. So I'd take that 0.2 divided by 3.2 and get 0.06. 1 divided by 10 gives me 0.1, and 0.25 divided by 1.75 is 0.14. Take the average, that comes out to 0.10. And I'll let you pause if you want. You can work through number of passengers, but it's exactly the same methodology. You take your number in that cell divided by the sum, do that all the way across, and then take the average, and that ends up being your weight. All right, and then the key now is we can go ahead and do a quick check and find our sum, right? So we add our 0.37 crash test rating weight, our 0.1, our city miles per gallon weight, and our 0.53, our number of passengers weight, and that better equal 1.00. If it doesn't, we made a calculation error and we need to go back and check our math. So this is what we call the analytical hierarchy process, or the pairwise comparison method. Next up, we will look at how we calculate weights using the swing weight matrix.